NASA has released audio of a black hole to give the public an insight into the vastness of the universe. The audio debunks the misconception that space has no sound because it's a vacuum. NASA used the gas released by a nearby galaxy cluster to pick up the sound waves around the black hole. The original noise is too low for the human ear to detect. The galactic groan heard is 144 quadrillion times higher than the original frequencies picked up by NASA. Scientists used a process known as sonification to resynthesize the sound waves into the range of human hearing. Joining us live now is Dr. Sara Webb, astrophysicist at Swinburne University. Really appreciate your time, Dr. Webb. The sound that we just played there, it was pretty spooky. What was your reaction to hearing that? Were you surprised that that's what a black hole sounds like?
It is, first of all, very spooky, but not surprised, only because black holes, they're very mysterious, but they are doing a lot to the environment that they are around. So what we're hearing is those pressure waves radiating out from this rotating black hole and hitting all of that hot dust and gas. And the process of sonification is incredible because it means that we can take data, which is really just numbers in a computer, and transfer it into something more enjoyable for us to try understand, because if it was just numbers, it wouldn't be as well, would it?
No. So I am right to think that elsewhere in space, it is relatively silent?
So elsewhere in space, so if you were in space right now, you couldn't hear anything because most of space is a vacuum. But there are parts of space that are really, really dense, really, really compacted with dust and gas. And if you were in those regions, you potentially could hear something. These sound waves, though, were so low pitched, even if we were dead smack next to that black hole, we could not hear them.
It does seem like we're learning a lot more about black holes in recent times. What have we learned recently? How big can they actually get? Can they swallow up things like stars, for example?
They can. So black holes come in a few different flavors. So we know that we have stellar mass black holes, which is when stars bigger than our sun die. We get a black hole that's itty bitty, but still a couple times the mass of our sun. We know that we get supermassive black holes, which is this one that we just heard here. These are millions and millions times the mass of our sun. They are absolutely enormous, and they normally reside at the center of galaxies. What we're still trying to figure out, though, is how do we go from these very tiny black holes to a very, very big black hole over evolutionary periods in the universe. And we've had incredible findings in the last few years about little black holes merging together using the LIGO and Virgo detectors. So I think we're on the way to solving the mystery of how they get so big and what they do to the environment, because most of them actually don't eat that much.
Very interesting. Dr. Webb, I'm getting the sense, probably safe to assume that you're getting pretty excited about a big event coming up in a few days. NASA's moon mission for next week sounds like it's on track. What's the plan? What will happen? What's NASA hoping to achieve?
So on the 29th, we should be seeing the Artemis rocket, Artemis 1 takeoff, which is a combination of the Space Launch System, so the rocket bit that we see, and the top bit, which is the Orion space capsule. And we can think of this as the brand new Apollo generation, but for the 21st century. So they will be blasting off, orbiting around the moon. They will be dropping down some cube satellites while they're there, and then coming back. And it really is a test run to make sure that everything that we know should work actually does before we put humans on top of it.
And when should that be happening? What's the time frame?
The 29th of August, and there's about a 3-hour window. And if it isn't able to launch because of weather or other issues, then over the next couple of weeks, we should see that launching.
In terms of humans going back onto the moon, though, how far off is that? And why has it taken so long for us to go back there?
Yeah. So in terms of seeing humans land on the moon again in the next 5 to 10 years is the Artemis program's plan. And it has taken so long because once the Apollo program budgeting was cut, it takes an incredible amount of resources and people power, engineering, everything under the sun to develop a program that is capable of sending humans around space very safely. And a lot of that energy was channeled into the International Space Station, which has been an incredible resource. I'm lucky enough to help send experiments up there, and that has told us so much of microgravity that now we have a better understanding of space in general and how our bodies react to it. And we also have the technology to be able to build systems that are cheaper, possibly more reliable, and will be able to carry more stuff, more weight. So I think it's a very, very exciting time.
It certainly is, Dr. Webb. Thank you for that. We appreciate your insights and looking forward to that launch next week. It'll be great to see. Thanks so much.
Thank you.